Students, in lecture 3 of thermodynamics, let's go to next first law of thermodynamics. What does this law states actually? According to this law, students, some heat is supplied to a system, right? Let we want to do some work and we give some heats. We're giving some heat means endothermic, right? In any of the reaction, if it will be, and the system is capable of doing some work, right? And then the quantity of heat absorbed by the system, how much heat is absorbed by the system, we are giving some system, that is equal to sum of the increase in its internal energy. That means the heat that you are giving, it is trying to increase the internal energy. Some work will be done internally for it by the help of that energy, right? And some of the external work done. External work done, how you will know? Means how much work is done on the surroundings by the system. Okay. And this is also nothing, that means overall it says that no energy is wasted. How much it is you are giving, that is somehow converted to some work done, and externally some work is also done. So that's why in mathematically we can write delta Q is equal to delta U plus delta W. That means heat supplied to the system by the surroundings, how much heat you are giving, that will be converted to delta W is work done by the system on the surroundings, and delta U is change in internal, delta U is change in internal energy of the system, how much energy we are getting. We'll take an example to understand that, right? Let's see. So let's see here. Suppose a system, that is a gas is contained in a cylinder, right? You are seeing here, with provided with some movable piston. This is the piston, right? And the gas does work in the moving piston because there will be expansion or compression, right? Then the work done by the system, already we have done this one in the last class. Work done by the system is equal to force into distance, right? Work is equal to force into distance, yes or no? And force is equal to how much? Pressure into area. So we can write force is equal to pressure into area into distance, right? And here let you are giving P pressure and the area of the piston is A, and let it is moving a distance dx, right? And already you know that P dw is equal to P into A into dx. That is small change in volume. This is the small change in volume, right? Yes or no? Because A dot dx is nothing but the change in volume. Area is not changing, distance is
Yes.
changing, change in volume. So that is dw is equal to p delta v. And so from the first law of thermodynamics, you can write dq is equal to how much? Du plus, in place of work done, what you can write? P delta v, right? So this is the small explanation about the first law of thermodynamics, but there is something that you should understand, right? So what means, we'll take a practical example on that. So before to that just keep in mind, when work is done by the system on the system, how to know those things, right? So there is certain sign convention here. So that is very important to understand. Let's know the sign conventions. From the sign conventions only you can know whether heat is given or heat is coming out, right? So it's like number one, let for heat exchanged, right? For heat exchanged delta Q. How much it is exchanged? Delta Q amount of heat is exchanged. So heat is supplied to the system. That means you are giving heat to the system. Heat is supplied to the system, right? We are supplying the heat to the system. Getting the students? You are giving the heat to the system. Heat is supplied to the system. But who is giving the heat? The surrounding. From the surrounding it is given. So that means here delta Q will be positive. And is heat is removed. यहाँ पर heat supply हुआ system को. Heat is removed from the system. तो delta Q को क्या लेंगे students? Heat removed from the system. यहाँ पहले केस पे क्या हुआ? सिस्टम को दिया गया heat is supplied to the system by the surroundings. यहाँ पर लिख दो heat is supplied to the system by the surroundings. सिस्टम को हमने heat दे दिए, तो डेल्टा क्यू का सिंबल क्या लेंगे? पॉजिटिव. अगर heat remove हुआ from the system, then delta Q क्या ले लेंगे? नेगेटिव, right? Yes or no, students? This is for heat exchange. And number two is work done. How to know for work done, right? Students, see. So work is done by the system. Okay. Work is done by the system. Work is done by the system. Work done by the system. So work done by the system means delta W will be positive. We'll take examples for this. Work done on the system, right? Work done on the system. Work done on the system by the surroundings. right? Delta W is equal to how much? Negative, correct? Yes or no? And triple number 3 for internal energy. For internal energy, right? So internal energy means U. So internal energy means increase in internal energy, right? So delta U positive, increase in the internal energy. So that will be positive. Decrease in internal energy, then we'll take what? Delta U is negative, right? So these things just keep in mind to understand, right? Let's take an example to understand this one, students, right? Any of the question if given, then by seeing the question only you can know where delta Q is becoming positive or negative, where delta W is becoming positive or negative, and delta U is becoming positive or negative. So from that value only you can know whether heat is given to the system or heat is released, right? Whether work is done on the system or work is done by the system, right? If whether internal energy is increasing or internal energy is decreasing, right? From these values you can know. So let's take one example given. The volume of a system provided by 1 gram of water at 100 degrees centigrade is this much, right? Calculate the change in internal energy during the change of state. That means this much of water will be converted to steam, correct? And students, here, let's go to the question. Students, how much given? Joule's law of mechanical equivalent of heat, 4.2 10 to the 7 arc per calorie, right? Yes or no? Mass of water, students, given how much? Mass of water, that is 1 gram, correct? And temperature of the water is how much? 100 degrees centigrade, है ना? Initial volume how much, student? See here. 1 gram of water at 100 degrees centigrade, right? Is 1650 centimeter cube. Calculate the change in internal energy during the change of state. Yes or no? Let's take that is 1 centimeter cube. Initial volume was 1 centimeter cube, and final volume is becoming, student. This is initial volume, right? This is initial volume, and V2 is how much? 1650 centimeter cube. That is final volume, right? And here next is given acceleration due to gravity is given, that is 981 centimeter per second square. Just wait, let's see what is the change in volume first, because that will be giving us work done. Change in volume is equal to V2 minus V1, right? That is 1650 minus 1, how much? 1649 centimeter cube, है ना? Students, here when 1 gram of water at 100 degrees centigrade is converted to 100 degrees steam, how much heat is required? We want to change the state now. That is latent heat of vaporization, right? 540 calorie per gram, है कि नहीं? 1 gram of water at 100 degrees centigrade is changed to steam at 100 degrees centigrade. Steam at 100 degrees centigrade, correct? So that means, student, how much heat is supplied? Here temperature remains constant, so you cannot put Q is equal to MC delta T, right? So you will put here Q is equal to ML. Yes or no, students? So the delta Q, how to calculate? ML. If temperature will be changing, then we will be putting MC delta T, right? So that is 1 into 540, that is equal to 540 calorie. If I'll convert this into arc, then 540 into 4.2 into 10 to the power 7, as per the question given, this much arc of heat is required. And pressure is equal to how much, student? Pressure is equal to how much? Pressure is equal to 1 atmospheric pressure, nothing given, right? That is atmospheric pressure we have to take, because 76 centimeter into 13.6 density of mercury into 981, right? So from there we can calculate. Getting or not, students? We can calculate na pressure, and we want to find internal energy. Internal energy how much? Du is equal to delta Q minus dW, and that is delta Q minus dW is how much? P into delta V. Yes or no, students? And delta Q how much? 540 into 4.2 into 10 to the 7. Just now we got na? Yes or no? Are you getting all? Minus how much? 76 into 13.6 into 981 into, students, P delta V. Delta V how much we got here? Change in volume 1649 na? Yes or no? So this is the question, then you can get it here. So that is 21.01 into 10 to the power 9. That is 2.1 into 10 to the power 10 erg. So this is the change in internal energy. Just see this one, students.